Hello, this is Math 2233 coming to you from the College of DuPage. This is the conclusion of the lecture entitled Lines, Planes, and Distances, and we're going to be talking about distances. And as always, I encourage you to be an active learner as you watch this video. Let's begin with kind of a bit of a theoretical thing, but I think it's useful for you to give this a go. Find a formula for the distance d from a fixed point, P1, which we call x1, y1, z1, to the plane given by a, x plus by plus c, z, plus d is equal to 0. You know what to do. Let's see how you did. So here is the deal. You have this fixed point up here. You have a plane sitting down here. And so what we're going to do is we're going to get a point here in this plane. And then we're going to look at the vector joining that point in the plane with P1. And this D is going to be the projection of B onto this normal vector. And then the magnitude of this is going to be the length from here to here. Okay, so here we go. So let P0 be any given point in the plane, and let B be the vector corresponding to connecting P0 with P1. So B is equal to, and we're calling this point x0, y0, z0, and x1, y1, z1 respectively. So B is going to be the difference between the two. So it is x1 minus x0, y1 minus y0, z1 minus z0. Okay, so now what we're going to do is D is the projection, and in fact D is the magnitude of the scalar projection, and the scalar projection formula is n dot B over the magnitude of n. And so we substitute all these things in. Let's see, n is going to be A, B, C. So we have that, and then we're dotting that with B, so we get this, this product here. And then this is divided by the magnitude of n, which is the square root of all those things. And we can reorganize this. And if we do, you see that we're subtracting off ax0 minus by0 plus cz0, and that is going to be, let's see, actually there's a mistake here. This should also be a plus. This one right here, this sign. So anyway, we end up with this, but you see this is going to be minus D because this P0 was originally in the plane, so it satisfies this equation. That makes this minus D. And so the equation can be simplified further to be D is equal to the magnitude of 8x1 plus by1 plus cz1 plus D, the absolute value of that, all over the magnitude of the normal vector, the square root of a squared plus b squared plus c squared. So that is the answer, and that's a formula that you want to commit to memory. So that was from a point to a plane. In this problem, we want to find the distance between parallel planes. And these two planes are parallel because the direction numbers for this one are 10, 2, minus 2, and this is 5, 1, minus 1. And so they're scalar multiples of each other, so these are parallel planes. You know what to do. Let's see how you did. Okay, the planes are parallel. We've already talked about that. And so to find the distance between the planes, we choose any point on one plane and calculate its distance to the other plane because they're all the same distance from each other. So in particular, if we put y equals z equals 0 in the equation of the first plane, we'll have 10x is equal to 5, and so this point is a point in that plane. So the distance between that point and this plane is given by this equation. We plug in all the numbers and we get the square root of 3 over 6. So that is the distance between the two planes. Here's another problem for you. In example 3, we talked about these things being skew lines. So we proved that earlier, but now we want to find the distance between the skew lines. You know what to do. Let's see how you did. So since the two lines are skew, they can be viewed as lying on two parallel planes, P1 and P2. So the distance between L1 and L2 is the same as the distance between the planes, which can be computed as in the previous example. So the common normal to both planes is going to be the 1, 3, minus 1. That's the direction of L1. And V2 is going to be 2, 1, 4. Those are both pointy brackets. So the common normal to them is going to be the cross product of the two. We compute it here. Make sure you can do these calculations. And we get that this is pointy bracket 13 minus 6 minus 5. Okay, so now if we put x equal to 0 in the equation of line 2, we get this point that is on L2. And so an equation for P2 is given by this, since we have the point, and so we get this as the equation. So now we set t equal to 0 in the equation for L1, and we get that this point is on P1. So the distance between them is the same as the distance from this point to this plane. And here's the formula. We get 8 over the square root of 30. Make sure you check you can do these calculations. And 8 over the square root of 230 is the exact answer, but it's approximately 0.53. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now more than ever, take care of yourself and of each other. May God bless you all till we speak again.